A well-designed corrective and preventive action process does more than correct an individual problem. It helps an organization learn from failures, eliminate systemic causes, prevent recurrence, strengthen processes, and support continuous improvement. Corrective and Preventive Action, or CAPA, is a quality management process used to fix problems and stop them from happening. Corrective action fixes an issue that already happened. Preventive action stops a potential issue before it starts. Together, they help organizations improve work systems and follow industry rules. One of the most important concepts in CAPA training is understanding the difference between correction, corrective action, and preventive action. A correction addresses the immediate problem. Examples are removing damaged product, repairing a broken guard, cleaning a contaminated surface, replacing a missing label, adjusting a machine, and stopping an unsafe activity. A correction answers, what can we do right now to fix the immediate problem? A corrective action addresses the cause of an identified problem to prevent it from happening again. An example situation includes problem: employees repeatedly fail to complete a required inspection. Correction: complete the inspection that was missed. Corrective action: determine why inspections are being missed and modify the process, responsibilities, training, tools, or controls that caused the failure. A preventive action addresses potential causes of problems before they result in an actual failure. An example is, a facility identifies that one production line has an inadequate inspection process. Before another line develops the same problem, the organization reviews inspection procedures across all lines and strengthens them where necessary. A problem is not truly corrected when the immediate issue is fixed. A problem is corrected when its cause has been addressed and evidence demonstrates that the problem is unlikely to happen again. Ultimately, an organization should only pay for a problem once. The CAPA mindset can be summarized as identify, contain, investigate, find the cause, correct, prevent, verify, and sustain. Using a systematic approach to corrective action ensures that organizations fix the true root cause of a problem instead of just treating the surface symptoms. The core steps in the CAPA process include 1. Identification and recording the details. Ultimately, there is no process with an issue to resolve. So the first step is to spot the issue. They may arise through customer complaints, audit findings, internal rejects, data trends, or a myriad of other causes. And document the problem clearly with initial facts and data. 2. Evaluation and prioritization. Assess the risk, severity, and urgency of the problem. This information will drive the immediate and long-term actions that will be required. Then decide if a full formal CAPA investigation is required. 3. Investigation and Root Cause Analysis, or RCA. Investigate the underlying source of the failure using tools like the 5 whys or fishbone diagrams. Attempting to correct the problem without understanding why it occurred is an exercise in futility. Avoid fixing just the surface symptom to ensure the real cause is found. 4. Action Plan Development and Implementation. Create a clear plan detailing the corrective steps, responsible parties, and deadlines. And apply the fixes to the process, equipment, or documentation. And 5. Verification of effectiveness. Monitor the process over time to confirm the fix actually solved the issue and did not create new risks. And close the CAPA formally only after proving success. When should a CAPA be initiated? Not every minor issue requires a formal CAPA. Organizations should establish criteria for determining when a CAPA is appropriate. Potential CAPA triggers include quality problems such as repeated product defects, customer complaints, product specifications not being met, rework or scrap trends, and failed inspections. Safety problems include workplace injuries, near misses, recurring unsafe conditions, equipment guarding deficiencies, and repeated safety observations. Compliance problems comprising regulatory findings, internal audit findings, certification audit nonconformities, procedure violations, and documentation failures. And operational problems including equipment failures, process interruptions, repeated downtime, inventory discrepancies, communication failures, and recurring production errors. When assessing the risk, severity, and urgency, it may be valuable to ask the following questions. Has the problem happened before? Could it happen again? Could it affect product, people, customers, or the organization? Is the problem systemic? Is the cause unknown? Does the problem involve a regulatory or certification requirement? Could the same problem exist elsewhere? And is the immediate correction sufficient, or is deeper investigation needed? One way to assess the criticality of an issue is to conduct a risk analysis. A risk matrix like the one you see here is commonly used. To the left, the levels of likelihood are charted, and across the top the severity levels. Likelihood in a risk assessment is the estimate of how probable it is that a specific adverse event or threat will occur, or occur again. The 5 common levels of likelihood are: rare. The event is very rare. It has less than a 10% chance to happen and only occurs in special cases. Unlikely. The event is not expected to happen. It has a low 10% to 40% chance to occur. Possible. The event might happen sometimes. It has a 40% to 60% chance to occur. Likely. The event will probably happen. It has a 60% to 90% chance to occur. Almost certain. The event is very likely to happen. It occurs often or has a greater than 90% chance to happen. Severity or consequence measures how bad the worst-case outcome could be if an issue actually happens. The 5 severity levels include insignificant or negligible. These can be minimal food safety or quality impact, off flavor, discoloration, or minor aesthetic defect, with no adverse health effects or symptoms expected. Minor. Mild discomfort or transient symptoms, short-term non-serious illness such as mild self-limiting digestive upset, and rarely requires professional medical treatment or intervention. Moderate. Noticeable health effect with clear short-term symptoms, medical attention or outpatient doctor visit required, and recovery is expected without long-term impairment. Major. Severe illness, clear long-term health effects, or hospitalization, significant threat to vulnerable consumer groups like the elderly or pregnant individuals, and typically triggers mandatory regulatory reporting or localized product recalls. And catastrophic or severe. Life-threatening consequences, permanent disability, or death, severe widespread foodborne outbreaks such as Clostridium botulinum or virulent Listeria contamination, and demands immediate public health intervention and wide-scale market withdrawal. To determine the risk level, the first step is assess the hazard or problem based on likelihood of occurrence, and the severity consequences if it did happen. And then find where those 2 levels meet on the risk matrix. For example, a negative event occurs and an analysis is done. The event control procedures would be reviewed to evaluate the likelihood of recurrence, and the result is that it is determined to be likely. Then the severity risk as moderate. Where these 2 categories cross is determined to be high. So this will drive a more thorough CAPA process than one that was rated as a lower risk level. A corrective and preventive action plan is not typically a solo event. It takes a team. A team is usually a small, multidisciplinary group that investigates systemic problems or failures to determine ways to prevent or mitigate them to the extent possible. The key roles on a CAPA team generally include team leader or facilitator. They guide the meetings and processes, keeping the group focused, and ensures the tools and methods are used correctly. Subject matter experts or SMEs. These are specialists on the system or process that failed to perform as designed. They provide deep technical or theoretical knowledge about the specific system or machine involved. Process owners and frontline workers. They bring and share real-world insight because they work hands-on with the process every day. Quality assurance and/or safety representatives. Depending on the nature of the incident, it may be valued to have these positions available. A quality assurance rep may provide insight of the finding or nonconformance if the issue, especially if it was identified during an audit. Similarly, if the core issue was safety-related, then having a safety rep may provide value on the requirements or standards during the process. Data analyst. They collect and analyze logs, metrics, and timelines to back up findings with hard facts. Depending on the complexity of the problem, it may be beneficial to have a recorder or scribe who documents the findings, maps out timelines, and captures the brainstorming and evidence, ensuring a thorough record. There are several considerations for corrective action meetings. Some include scheduling a meeting ahead of time so that all participants can plan to attend. Hold it in a space appropriate for the needs of the analysis with the table space, chairs, audiovisual equipment, dry erase boards, and whatever else that will be needed. Depending on the organization or workspace being used, supplies may need to be acquired, such as pens, highlighters, notepads, dry erase boards with markers, corkboard, sticky post-it notepads, page markers, or whatever the team may need to be efficient. And lastly, printing out copies of relevant policies, procedures, and manuals may save time once the group gets started. Now let's get into the corrective and preventive action plan process. Step 1. Identify and clearly define the problem. A CAPA cannot be effective if the problem is poorly defined. Identifying and defining a problem means recognizing that a gap exists between the current undesirable state and the desired ideal state, and clearly stating what that core issue is before looking for answers. Avoid vague statements. Instead, define the problem using objective information. A good problem statement identifies: what happened? Where did it happen? When did it happen? How often did it happen? What requirement was not met? What evidence demonstrates the problem? What was the actual or potential impact? An example of a weak problem statement is: sanitation is not being done correctly, versus a strong problem statement, such as: during 3 sanitation verification reviews conducted between August 5th and August 12th, the post-sanitation inspection identified visible residue on the conveyor framework and packaging line 2. The sanitation procedure requires the equipment to be visually free of product residue before release. The second statement provides something that can actually be investigated. Step 2. Immediate containment. Before investigating the root cause, control the immediate risk. Immediate containment refers to the urgent, short-term actions taken during an incident or issue to control the situation from spreading before permanent fixes are applied. It is important to understand that containment is not the same as corrective action. Containment controls the current situation. Corrective action eliminates the underlying cause. Containment may include stopping production, holding affected product, isolating materials, correcting equipment conditions, increasing inspections, removing affected product from distribution, notifying appropriate personnel, implementing temporary controls. An example would be: if an allergen labeling error is discovered. Containment. Place affected product on hold and prevent shipment. Root cause investigation. Determine why the incorrect label entered production. Corrective action. Correct the process that allowed the wrong label to be issued or used. Preventive action. Evaluate similar labeling processes throughout the facility. Step 3. Gather evidence. Effective CAPA decisions should be based on evidence rather than assumptions. Evidence gathering is the systematic process of collecting, recording, and preserving facts, data, or documents to prove whether a claim, hypothesis, or suspicion is true. It replaces guesswork with verified information to support decisions, investigations, or legal cases. Evidence may include production records, inspection records, monitoring records, maintenance records, training records, audit findings, photographs and video, interviews, customer complaints, test results, equipment history, process data, trend analysis, and previous CAPAs. Step 4. Conduct root cause analysis. Root cause analysis determines why the problem occurred. A root cause analysis, or RCA, is a structured problem-solving process used to identify the fundamental, underlying cause of an incident or defect rather than just treating its visible symptoms. The goal is not to identify someone to blame. The goal is to understand the system that allowed the problem to occur. Some methods for conducting a root cause analysis are 5 Why, fishbone diagram, failure mode and effects analysis, and fault tree analysis. The 5 Whys has the analysis team ask why repeatedly until the underlying cause is identified. Here is a quick example of the process. The problem is the product was shipped with an incorrect label. Why? The wrong label was applied. Why? The operator selected the wrong label. Why? 2 labels were stored together and looked similar. Why? The labeling storage system did not adequately distinguish allergens and product types. And why? The facility had not established a standardized label segregation and verification process. The potential root cause of this issue is an inadequate label control and segregation process. It is important to be able to distinguish between symptom, contributing factor, and root cause. A symptom is what is visibly wrong. A contributing factor is something that helped create the problem. And a root cause is the fundamental system or process condition that allowed the problem to occur. An example for problems such as an employee failed to perform required inspection would be: here a symptom would be the inspection was not completed. A possible contributing factor is the employee was busy. And a possible root cause could be the inspection responsibility was not clearly assigned and the process contained no effective accountability or verification mechanism. Step 5. Develop corrective actions. Once the root cause has been identified, determine what needs to change. Corrective action is a process used to fix a problem, so it does not happen again. It applies to both business operations and employee performance management. A strong corrective action should address the root cause, be specific, be measurable, have an owner, have a completion date, include necessary resources, be practical, and reduce the likelihood of recurrence. A weak corrective action statement would be retrain employees. Although this is commonly used, it is likely not going to address the root cause. A stronger corrective action statement would be: revise the label verification procedure to require a documented 2-step verification before line startup and retrain all affected personnel on the revised procedure. A good way to determine if the corrective is effective or not: ask what changed in the system? If the answer is nothing, the corrective action may not be strong enough. When developing actions, encourage participants to consider stronger controls before relying solely on reminders or retraining. In the safety realm, the hierarchy of controls is used to implement techniques to minimize the chance and impact of workplace hazards. This concept can also be applied to corrective actions. The levels of the hierarchy include: eliminate the source of the problem. This is the most effective way to permanently correct the issue where the problem is removed from the chain. Redesign the process. Often called business process re-engineering, is the rethinking and overhaul of organizational systems. Its core aim is to achieve measurable improvements in speed, cost, quality, and customer value, or making small, incremental tweaks, depending on the scope of the problem. Engineering or physical controls. These are physical barriers put in place to prevent the introduction of the problem. This can be modifying equipment, implementing automation, installing ventilation, sound enclosures, etc. Administrative controls. These organizational changes that intend to prevent the introduction of the problem. They can be things such as changing employee behaviors, policies, and operational processes, or updating or reinforcing strict standard operating procedures. Mistake proofing, also known as POCA Yoke A, is a quality control method designed to prevent human errors or make them immediately obvious before they turn into defects. An example is color-coding cables and connectors so they are plugged into the right plug. And improve training or retrain. This is typically a go-to as a corrective action. But as you can see in the hierarchy, there are a lot of options that should be considered before arriving at training. Other options that can be considered include improving monitoring and verification processes, and increasing supervision and/or accountability. Step 6. Develop preventive actions. It is a proactive step taken to identify and eliminate the causes of potential problems or nonconformities before they actually happen. Preventive action asks, where else could this happen? Once a root cause has been identified, determine whether similar risks exist in other production lines, other departments, other shifts, other facilities, similar equipment, similar procedures, similar products, and similar processes. Some core considerations include a proactive focus. It looks ahead to stop issues from occurring for the first time. Risk reduction. It uses data, audits, and risk assessments to find weak spots in a system. And continuous improvement. It supports quality management standards, like ISO systems, to keep operations safe and efficient. People often group these preventive and corrective actions together, but they mean different things. Here are the differences. Timing. Preventive actions are proactive, implemented before a problem happens. And corrective actions occur after the problem surfaces, and therefore reactive. The goal of preventive actions is to prevent occurrence, where a corrective action's goal is to prevent recurrence. The trigger for a preventive action is an identified risk or potential weak spot, versus a corrective action that is triggered by an existing defect, error, or failure. An example of a preventive action is servicing a factory machine before it breaks down, and a corrective action is repairing the machine after it breaks down. Step 7. Develop the Corrective and Prevention Action Plan. A corrective and preventive action plan is a structured problem-solving process used to fix an existing issue based on its root cause and stop it from happening again. A robust corrective and preventive action plan outlines the specific corrective and preventive actions that will be taken to address the root causes and prevent recurrence. Once the root causes of a nonconformance or deviation have been identified through thorough investigation, the next critical step is developing and implementing an effective corrective and preventive action plan. Every plan should clearly identify the action. What will be done? Root cause. What cause is being addressed? Owner. Who is responsible? Resources. What is needed? Deadline. When must it be completed? Evidence. What proves completion? And effectiveness. How will success be measured? Step 8. Implement the Corrective and Preventive Action Plan. Application requires more than assigning an action. Implementing a corrective and preventive action plan requires a structured, step-by-step process to fix current problems and stop them from happening again. With a formal, approved corrective and preventive action plan in place, implementation of the defined actions should follow a systemic approach with clear timelines, resources, and oversight. Key steps include detailed planning of each action item, securing necessary resources, such as personnel, budget, equipment, etc., executing corrective and preventive actions per the plan, Documenting all completed actions. Verifying the effectiveness of actions taken. And revising the plan as needed based on the results. Communication and training are vital during the plan's implementation, ensuring all affected personnel understand their roles and responsibilities. Leaders should ensure employees understand the change, including the why that is driving it. Procedures are updated. Training is completed where necessary. Equipment or process changes are completed. Resources are available. Temporary controls remain in place until permanent controls are implemented. And changes are communicated to all affected departments. A corrective and preventive action plan frequently results in process changes. Therefore, organizations should evaluate the impact of the change. Training required to ensure personnel have the knowledge and skills to enact the new process. Documentation requirements or needed updates. Safety implications, as well as additional or new controls. Quality implications and inspection requirements to validate the new processes are upheld. Regulatory compliance implications. Maintenance requirements, especially preemptive and predictive measures. And validation or verification requirements. Step 9. Verify completion. Verifying completion of a corrective and preventive action plan requires confirming that all assigned tasks are finished and proving that the actions successfully prevent the problem from coming back. Completion does not prove effectiveness. Completion verification asks, did we actually do what we said we would do? When completing verification, evidence may include revised procedures, training records, photographs or videos, work orders, purchase records, inspection records, updated forms, and completed implementation records. For example, training records show that employees attended training. That proves the training occurred. But it does not prove employees are correctly performing the task. Observations, inspections, or audits should supplement the verification process. Step 10. Validate effectiveness. Validating the effectiveness of a corrective and preventive action plan requires reviewing objective data over a set monitoring window to prove that the root cause is eliminated and the problem does not recur. Effectiveness validation asks, did the action solve the problem? This is one of the most important stages of corrective and preventive action process. Effectiveness can be demonstrated through follow-up audits, trend analysis, repeat inspections, product testing, process monitoring, complaint reduction, reduce defect rates, improve compliance, observation of employee performance, and verification of process controls. Here is an example. The problem is repeated packaging machine failures. The action is to revise maintenance procedures and retrain employees. To measure effectiveness, conduct unannounced inspections over the next 30 days and compare results with the previous baseline. If failures continue, the corrective and preventive action plan should not simply be closed. Step 11. Close the corrective and preventive action session. Closing a corrective and preventive action plan requires verifying that all tasks are completed, checking that the solution actually solved the root cause, and obtaining formal sign-off. A corrective and preventive action plan should only be closed when there is sufficient objective evidence that the problem was properly investigated, the root cause was identified, immediate containment was completed, corrective actions were implemented, preventive actions were implemented where appropriate, required documentation was completed, effectiveness was verified, and recurrence risk has been reduced to an acceptable level. Ineffectiveness and problems with the corrective and preventive action process can lead to regulatory action, product recalls, injuries, loss of reputation, and a myriad of other issues. Recognizing potential issues and working to prevent or mitigate them before they surface is crucial to the success of the process. Here are some common mistakes can include. Mistake 1. Treating the symptom. Managing the visible signs of an issue without fixing the root cause. This is the result failing to perform a root cause analysis or stopping the process before the true root cause is identified. An example is clean the equipment. The immediate problem is corrected, but the cause may remain. Mistake 2. Automatically blaming the employee. This is the result of a toxic management habit that ignores systemic issues and destroys team trust. The fix is to focus on processes, not people. Ask: was the procedure clear? Was the employee trained? Was the correct equipment available? Was there adequate time? Was the employee supervised? Was the process practical? And were expectations clearly communicated? Mistake 3. Using retraining as the universal solution. It is a major red flag because human error is rarely the true root cause of a quality failure. Training or retraining often is a component of a corrective action process, but should not be the main method. Like the previous issue, focus on processes, not people. Training is appropriate when lack of knowledge or skill is the root cause. It is not appropriate when the actual cause is poor equipment design, confusing procedures, inadequate resources, poor communication, excessive workload, missing controls, inadequate supervision, or process design problems. Mistake 4. Weak problem statements. A weak problem statement is one that is too vague, assumes a solution, or lacks supporting data, which prevents a team from finding the real root cause of an issue. A problem statement must be clearly understood by the investigative team. Key factors of a good problem statement includes who, what, where, when, and how. Statements like employees aren't following the rules provides little useful information. Mistake 5. Stopping at the first why. This is the result of a narrow analysis. Though 5 in the 5 why analysis is iterative, most problems will need more rigor than a single why. The first answer is often a symptom rather than the root cause. Mistake 6. No effectiveness check. Failing to perform a real effectiveness check in a corrective and preventive action process means organizations close paperwork on schedule while the underlying failure mode remains unaddressed. Follow the processes to evaluate the effectiveness of the plan before closing out the issue. Mistake 7. No systemic review. Just because a problem surfaces in one area, one department, one shift, or on one machine, does not mean that it is restricted to that demographic. During the corrective and preventive action process, look where else the issue or a similar one can arise. This will save time later when it does present itself. A problem discovered in one location may exist elsewhere. Mistake 8. Unrealistic deadlines. On the workforce, it can cause severe burnout, lower work quality, and plummeting team morale. And when implementing corrective actions, it can turn the process into a paper drill with no measurable effectiveness. Effective corrective actions will take as long as they take. Instead of rushing, implement immediate actions to minimize the issue until the full corrective and preventive action plan is implemented. Corrective and preventive actions should have realistic deadlines that account for complexity, resources, purchasing, engineering, validation, and training. And mistake 9. No clear ownership. Here the process fails because tasks lack accountability, causing them to slip through the cracks and remain unfinished. There will also be a priority issue, in that there will be conflicting priorities with all the other work required by associated personnel. As the adage goes, if everyone is responsible, sometimes no one is responsible. Each action should have a clearly identified owner. An effective corrective and preventive action process is vital because it stops recurring errors, ensures regulatory compliance, and drives continuous organizational improvement. We hope you found this training valuable. We recommend that you share the video with personnel who participate in your root cause and corrective action processes to ensure everyone understands the basis for the process. Please click the subscribe button to access additional FSTG training videos.